We have set the configuration. We have set our configuration about the PLC. So let's come here. We have the PLC named S7 1212 DC DC DC. We have placed our digital input and output module in the second slot. And we loaded them. There isn't a problem right now, but we can load them again if you wish. So let's come here and load them again. There isn't a problem right now, but it loads successfully. I am selecting the no action setting, and by pressing download, I am starting the loading. Now you are seeing our linear process here. Now let's start the programming of our driver. So what is the first step of programming? At first, there is the technology objects section over here. We will be using the technology objects while performing the positioning operations. So I will go into the technology objects and click on add new object. I'll be making the access control via this section. So let's write access underscore x underscore PLC is the Ogran here. So we will be controlling the PLC is the Ogran X axis. That is the name of our block we will be using. So you can give any other name in accordance with your wishes. We will be doing this in the position control. So let's say OK after doing that. Access underscore x underscore PLC is the Ogran appeared under this after clicking on OK. So the pulses that we will be using here are coming as active. Now, which pulse generators will we be using here? Let's find that out. Look, we will procure a pulse generator or a PTO output by using the outputs of our PLC. These S7 1212, 1214, and 1215 PLCs have 4 pulse outputs. You will see this if you open their documents and look into the related section. This may also be case for the S7 1217. So this means you can drive up to 4-step motors, but I will explain the buts later. Now, let's select one pulse generator from this section. And as you see, I have selected the pulse 1. And it gave me the Q0.0 automatically. It is telling me that I can use Q0.0 as my pulse output. We can change this if necessary, but we don't have to. So I will bring this over here and take the Q0.0 of my PLC and then connect it to the pulse terminal of my PLC. I mean, this is an already necessary process. I already have to connect it there. Also, if I want to use the motor bidirectionally, I will have to bring this Q0.1 and connect it to this terminal here, this terminal. And I had already told you about this. But let me tell you this, if I don't activate this, I will be using this motor unidirectionally. Think of it like this, you have a one-way conveyor belt. If you will be using your step motor to roll this one-way conveyor belt, then you don't have to activate this. The moment you activate this, you will automatically have 2 outputs. Therefore, it will be like you are using 2 drivers instead of 4. That's something to remember. You can connect 4 different drivers in unidirectional operations. That's what I concluded from this instance. But I will say active direction output, and after saying that, I will provide bidirectional movement here because I have a linear system. Therefore, I have a system that goes both right and left. I need that in order to perform my operations. Now, let's move on to position unit settings. So we will be selecting the millimeter option in the position unit section for the moment being. We can change it to open control later, but right now we will set this linear system so that it can move to right and left using millimetric units. In the end, the parts on our conveyor belt needs to go right and left. We will be using millimeter control here. I should express that first. And apart from that, let's say that you have a toothed saw here and you will be welding something onto that saw. In that event, you shouldn't forget to perform that operation in open control mode. The settings here are done. So let's move on to the segment below. So what do you see when you look at the tab below? We wish to control our driver via our PLC. We wish to power it via our PLC. I will be powering my driver here by using an output of my PLC. So I said that before. I will be using the Q0.3 because Q0.2 is damaged. I will bring the cable from Q0.3 and connect it to the positive terminal of this. So my driver will be powered through my PLC. So what is the advantage of this? I will be able to power my driver as long as my PLC is on, or as long as I send commands through it. I will be able to cut and restore power through my PLC. Yet, if we have a high-powered step motor, or if its voltage is too high, then it is best if we use a roll instead. It's best if we power it via a roll in that event. So you should remember that. And let's do this. Look, I have done that as well. And this is also okay. So let's go to the mechanics section. This section is important. Friends, in this section we set the pulse per motor revolution, or how many pulses it generates in a revolution. So we had to set our driver to 800 pulses per revolution. Friends, you should also know this. How many millimeters will your system move in each revolution? So our system will move 1.4 millimeters with each revolution of our motor. We have already calculated this. Now, we calculated this by using our linear axis and wrote 1.4 millimeters here. And if you don't write this here, then there will be lapses and slips in your calculations and axis. So don't forget that. Here, friends, we will conduct a bidirectional movement. Thus, I selected the necessary options. So, apart from that, let's go to the position limit section. Friends, what do we have in this section? We have enable hardware limit switches and enable software limit switches option here. So this section is about hardware and software switches. It refers to hardware and software by SW and HW. Now this is what is about the hardware and software switches. So we have switches on our linear system here. These are physical switches. Therefore, these are hardware switches. So you will be selecting HW option if you are using physical switches like us. And we will be using just that. But let's say you don't have physical switches and you want your motor to travel to a location and come back, but you haven't installed these physical switches, then you will run the operation completely via software. In that event where you wish to make operations via a software rather than a physical switch, you will have to select the SW option, and thus your motor will travel back and forth according to the settings you have made. Friends, we will be selecting the HW setting because we have physical switches. Now, as you see in our system, I have two hardware switches, one on the left and the other on the right. So I will be designating those hardware switches. I am making the necessary calibrations now. Now I will come here and write 0.5 for my switch on the left. I'll say 0.6 for this one for my switch on the right. Now it says low switch and high switch. I have designated my left and right switches in the boxes above. Now the system requires me to select a level. It said low level there, and here is the high level option. Now look, my sensors and switches have normally open contacts. These contacts close when a signal hits. I mean, they go from 0 to 24. Therefore, I am receiving my signal from there and sending it to my PLC and perform the operation. Thus, I will be starting from 0 and stopping at 24. This is why I am selecting the high level for both of my switches.